My name is Okoli Evans. So I write Cairo language, Solidity, Rust, JavaScript, TypeScript, and all the rest. Yeah, so now we started with comparing the experience on Starknet with what happens at the nightclub. Yeah, because we wanted to use the real life analogy so that we can easily understand. Yes. So I mentioned that when you get to a nightclub, you first of all meet someone at the gate who we call a bouncer. So the person has to look at your ID and verify that you are at least 18 years before they can allow you entrance into the club. Then even in the club, the attendant attends to you, get your orders, serve your drinks and all the rest. After drinking, you make your payment. So they have to confirm your payment and then give you your receipt. So at the end of the whole business of the day, the manager or the supervisor will now go through the whole transactions and make sure that everything tallies before they now approve and then close the book for the day. So that's the normal flow of things at a nightclub. So now we say, let's bring this to Starknet. So at the gate, someone is checking your ID and making sure that you are up to 18 years. And then we have on Starknet, we have a mempool. In the flow of transactions on Starknet, we have a mempool that it collects all the whole transactions coming in. It now validates it to make sure that at least these transactions are valid before it can even pass to reach the sequencer. So the bouncer at the gate checking these transactions one after the other is the mempool. Also, by definition, the mempool is like a space on the blockchain where you have unprocessed transactions. So immediately someone sends a transaction on chain, it's going to stay in the mempool for maybe some milliseconds or some seconds, and then it's going to be picked up by a validator or by the sequencer. Sequencer picks it up, then processes the transactions inside. So now, when we talk about sequencer processing transactions, we can liken it to the attendant, the bar attendant that accepts your orders and serves your drinks. So he takes your orders, how many drinks do you want? Okay, this is the amount. You agree, okay, they serve you the drinks. So that's the sequencer for you. Processing is processing your orders as they're coming in. Now we have the cashier that's collecting payment, and that's the prover for you. He collects payment, he gives you your receipt. The prover collects execution trace from the sequencer and then gives a proof, generates a proof for the verifier. And we mentioned that execution trace is like a sequence of all the transactions in a block or all the processed transactions. So it's a mathematical, maybe a polynomial sequence or something like that. But you don't have to concern yourself with the mathematical aspect of the prover or the sequence. So just know that the sequencer passes this execution trace to the prover. The prover looks at it, uses the execution trace to generate what we call a proof. A proof is like a mathematical computation of the whole transactions. So instead of having these transactions as as maybe as linearly as you have them, say this is they use the execution trace of like a summary of what happened and what we call state difference. That's who is sending what is basically who is sending this and who is getting this, like how you balance your books in the bank, debit and credit. So that's what the summary of that is what we have in your execution trace. The prover uses that summary to generate a proof. A proof is a stack proof. So the stack proof is what we pass to the verifier, who sees now like the manager or the supervisor of the bar. We gets the proof, then he has to just make some 1 or 2 calculations based on what we give him. So just random calculations, and if the temporaries, that means the record is okay. We now store it on Ethereum layer. So that's what the verifier does. By definition, the verifier is a smart contract on Ethereum blockchain. So let's see this. This is a verifier on Ethereum. If you look where you see here, you have L1 Ethereum. So Starknet is a layer 2 protocol built on top of Ethereum. I know we all of us know that. So it's a layer 2 protocol. It's like a scale up, what we call a roll up. Is a layer 2. Layer 2 means we have a layer 1, okay? And that layer 1 is Ethereum. Now, this is what I just explained. Mempool takes your transactions, and at the gate, you can see the gate here. We are doing the validations. So now we sift out the invalid transactions, send them, reject them, and then we pass the valid transaction to sequencer. Sequencer processes the transactions, build a block with them, put them inside blocks, what we call blockchain. That's how you get blockchain anyway. So you get the transactions, bundle them inside blocks. So you have this block containing maybe 100 transactions. Another block is the job of the sequencer to build the blocks and then pass the block with the transactions to the prover. Prover runs the transactions again, down generates a proof using the transactions. So the proof is being sent to verifier here. Verifier now checks, and then if it's valid, we store it on the base layer. That's the summary of the architecture of Starknet. So we also looked at what we call recursive proving and parallel execution. So I mentioned that earlier, sometime this year, I think a few months ago, Starknet released some new upgrades to their protocol. So earlier, before the upgrade, we have, we get a block, we prove the block, and then send to the verifier. But with the upgrade, we discovered that we can have what we call recursive proving. Instead of proving a block and sending each block of transactions, we prove it and send. We can have a system where we have proof, we have a proof, recursive proving. That's, we prove this, instead of sending that proof, no, we build another proof on top of it. Like when you have Merkle tree, I'm sure all of us know what, at least a number of us know what Merkle tree is and how it works. So instead of sending one proof, we use proofs to generate, concatenate proofs, like bundle proofs to generate one parent, or what we call Merkle root. So it's like using proofs to generate one parent proof. That parent proof, you can use that parent proof to verify the entire proofs that serve as the leaves. So when you have a Merkle tree, you have that. If you get a Merkle tree, I don't know whether you guys did data structures. So there, I think, is it table or so? There's a kind of data structure where you pick something like leaves, you join them, keep joining them till you get to the root. Then you can pick one of this and one of that, like join them like that. And using that stuff, the leaves, you can prove the entire leaves in the Merkle system. So it's kind of how this proof system works, the recursive proving. So you can use the parent proof or the final proof to attest to the validity of the entire proof system. So instead of having proof being sent one after the other, we bundle like maybe 10 or 20 proofs in one proof, and then we verify that proof. So that's like 10 times or more than 10 times improvement in speed. Okay. So instead of having this thing done one after the other, you can just bundle like 10 or 20 proofs and send them as one. And this is very fast. It makes the system very fast and very robust, and very efficient in handling load. So coming to parallel execution, we have that before the upgrade, we have a Starknet sequencer handling transactions one by one, first in, first out, one by one. But now, with parallel execution, what happens is you can have more than one transactions being processed at the same time. So I mentioned that we can liken it to the banking hall. So if you come to the banking hall, maybe you'll have one person attending to the whole. Let's say it's a Monday morning, people come to do businesses because it's Monday. Everybody wants to do business, start a business for the week. And you discover that it's just one person at the counter, handling transactions, collecting check and cash and, giving withdrawals. And you have more than maybe 150 persons in the banking hall. It's going to be chaotic and painfully slow. But when you have maybe you have 5 persons at the counter, each person is taking care of one customer at a time, the process becomes very fast and makes it easy on everybody. So that's the same idea of having a parallel execution on Starknet. So the sequence, instead of handling these transactions one after the other, it can handle more than one transactions at the same time, maybe 5, maybe 6. But there is a condition. So the condition is, oh, by the way, if you have questions, please drop them in the chat. Yeah, so once I will come back to check if there are any questions and they answer them before I continue. Yeah, so because if you say let you ask later, you might forget. Just drop them in the chat and I will attend to them later. So yes, the condition I was talking about is that these transactions must not depend. So for a transaction to be handled, it will not be depending on another transaction. So how do I explain this? So if you have that this transactions was sent and maybe it is okay, maybe you first sent a token to someone. Maybe you sent at least sent a token to Bob, and then also sent another token to maybe Idris. And the one you sent to Bob has not been processed yet. That means the one you sent to Idris cannot be processed because it has to be, there's what we call nonce. So it has to be sequential from a particular user. The one you send to Bob has to be processed first. The reason is because we have to get your balance after sending to Bob. So once the one you send to Bob is processed, we can now update your account. We can do plus and minus and do debit and credit, and then we minus from your account and give to Bob. So we minus the amount you sent to Bob, and then we now check the amount you are sending to Idris. Do you have them after you must have sent to Bob? So after you have sent to Bob, the remaining balance in your account, is it enough to cover the tokens you want to send to Idris? So that's why you need to, that's why you need to pass the transactions one after the other. So if these transactions are like this and they're depending on each other, they cannot go in parallel. They have to wait. But the ones that maybe I just want to send to someone independently from Alice. So Alice is a different person. Maybe Peter is another person that just sent a random transaction. So Peter's own can be happening at the same time with Alice's own. They can happen at the same time simultaneously, in parallel. But then the Alice own that will be sent to Idris, we have to wait for the first one from Alice to be sent to Bob before the Idris own can happen. So I'm taking time to explain this so that it will not confuse us. Although you can always read about it to get more insight. Okay, let's talk about account abstraction. Yeah, so this has been a buzzword. It has been a buzzword for some months or some years on the blockchain ecosystem. And while some protocols are, trying to create maybe the buzz that they are implementing account abstraction, everybody's marketing. But then this was inbuilt, like it is native to Starknet. It's built into Starknet by design. So what does account abstraction mean? Let's take this. Let's explain it using this analogy. So what happens if you expose your seed phrase or your private key? So assuming all of us are developers, assuming you mistakenly pushed your env file to GitHub and it contains your private key, and the private key is your mainnet, and you have some tokens on it. I'm sure you guys know that there are some bots that are monitoring GitHub repos. Within some seconds, they clear out the account immediately. So yeah, if you use your private key or you push it to GitHub, you've basically lost that account unless you move fast. So let's compare account abstraction with normal EVM wallet, EOS. So yes, okay. Your normal EVM wallets are something like MetaMask. So when you come to smart wallet, you have maybe Argent wallet that's now called Ready. Argent and Bravos is what we have on Starknet. So if you come to MetaMask, you have to create your wallet, copy your seed phrase, create enter password and all those. Yeah, on smart wallet, you also create wallet, also put password. But there is some more features on smart wallet. You can enable what we call Guardian. Guardian is if you want more if you want more security, you can enable Guardian. Guardian will be like a multi-sig to you, to that your account. So it has to, if you want to withdraw money, it has to include its signature for you to plus your own for their transaction to go. So you have Guardian, you have advanced features like you can log in not using only password. So you can log in using your Face ID, your fingerprint, your email, your passkeys, anything. So you find that smart wallets are programmable, very programmable and more advanced than what we have on EVMs. So you have that users must manually click, or tap to sign transactions. That's your normal pop-up when wallet pop up. Like if you want to send transaction, MetaMask will pop up. You have to like sign before the thing now goes. So on smart wallet, you can easily use your Face ID or your fingerprint or your passkey. So just use fingerprint. I think this happens even on Trust Wallet, use of fingerprint. I'm not sure, but I think so. But it's available on smart wallet like Argent, Bravos. Then you can do this. So on EVM, transactions must be sent one at a time. Yes, this is a big advancement on smart wallet. So on EVM, you cannot send more than one transaction at a time using your MetaMask. But on Argent or Ready Wallet, you can bundle more than. Actually, is there any way I can show you this? Before the end of maybe in this class or the next, I can show you how to bundle transactions. You can send more than one transactions. We call it bashing. So instead of normally when you are using EVM, you have to probably want to interact with an app. You first of all approve your token, which is the normal process we all know when you are using something like Uniswap or anything. You have to approve, then you come back again and rest for some seconds, and then the wallet will now come up again, and then you now sign. So going back and forth, trying to approve and sign and all those ones. But with bashing of transactions, what we just do is once just click on approve or on sign. On send, just click on send anything. Once it will handle the approval behind the scene. It will handle maybe deposit. It will also handle transfer. If you have 10, 20 transactions, all of them, it can go once, just in one click. So that's what you get with smart wallets. It's very advanced and it comes with a very big improvement on user experience part of stuff. So this also enabled us to build off ramp on like off-ramp services, wallet services on WhatsApp and Telegram. So you don't have to sign transaction or get wallet pop-ups on your inside your WhatsApp. You can just click, the whole thing goes. Yeah, it was achieved with cartridge control anyway. It's one of the tools on Starknet, wallet tools we use on Starknet. So private key exposure can lead to drain of your wallet. Yes, exactly. Because I asked what happened if you lose your private keys or seed phrase. If you expose your private key, your wallet is gone. But then we have seen on smart wallets, even if you expose your private key, once Argent, I'm talking about Argent now, once they notice a change in IP, they will require you to verify your account using your OTP before they can give you access to that account, if you like have the private key or not. So even if you have the private key, you don't have access to that account, they will still send you your email. They will ask you to enter your email. You enter your email, they send you OTP for you to verify that you are the real owner of the transaction. So with just your email, you can recover your wallet. So there's no fear of maybe you expose your private key and you lose your money. So it's rare, it's difficult when you are using smart wallets. So accounts are protected using two-factor authenticators like OTP, Face ID, fingerprint, passkeys. So yeah, on MetaMask, let me check if you have questions. Okay, no questions yet. So on MetaMask, they will tell you I think when you are trying to create an account, they will tell you that if you lose your password, they cannot help you to recover it. I don't know if you have seen something like that. If you lose your password, we cannot recover it for you. So that's Meta. I don't know about now. Maybe they have upgraded, but before, if you lose your password, you cannot have access to unless you have your seed phrase somewhere. That's the only way you can recover your wallet. But then with a smart wallet, you can easily use your email to recover your account. It happened a few days ago. One of my friends upgraded his phone. So what happened was that he bought a new phone. So he sent me all his tokens so that in case anything happens. But after he moved to the new phone, so he installed Argent Wallet, Ready Wallet now. So what happened was that immediately he opened the wallet and put his email. They sent him an OTP and he verified the OTP. His whole account was recovered. So it was not magic. His whole account, nothing was left. He got his whole account back just like that, just by entering your email and verifying your OTP. So we are getting what we are getting is like a Web2 experience. Web2 user experience now is what we are getting on blockchain. And this is what we have been fighting for some time. Yes. So user gas fees must be paid using ETH on Ethereum protocol. Yeah, so we have that you must pay gas fees using Ethereum on Ethereum protocol. On Starknet, we used to pay gas fee using only Stark. But now you can pay gas fee with any token at all, even if it's meme token. So you can pay gas fee using your Stark, your USDC, your ETH, anything you have at all that is token, you can use it to pay your gas fees on Starknet currently. So users must pay gas fee from their account. Yes, even though we had OpenZeppelin, I think OpenZeppelin Defender, OZ Defender, and by economy that you can integrate is like adding another layer of smart contracts on your own, so that you can have what we call Paymaster. Paymaster is like, okay, I have an app. I don't want users to pay gas fee. I want to pay gas fee for them, so I implement Paymaster. So instead of them paying gas fee, I'm paying from my bank or my safe. So users don't pay gas fee while they're using their account. That's what Paymaster is. So Paymaster is like you have your gas tank or just a pool of tokens. Yeah, if someone clicks on your platform to use, you send gas fee for them. Then everything now goes. Then they are paying zero gas fee. You are just covering the gas fee for them. Okay, so only one version of wallet exists for everyone. So MetaMask is MetaMask. You cannot customize MetaMask. Most on EVM, you don't customize wallets easily on EVM. But on smart wallet, with smart wallet and smart account, you can customize the wallet anyhow you want. So the only thing is, after, just check out, research SNP 6, Starknet Improvement Proposal 6. This is what SNP stands for, Starknet Improvement Proposal. So this proposal outlines the standard for that your smart wallet or your smart account must meet for it to be accepted on Starknet. Think both signature, algorithm, and the rest. But besides this, I think just three functions: execute, validate, and is valid. These three functions, they are the only ones that are compulsory. The signature algorithm you want to use, you are free to implement anything you want as validation. So if you validate and do everything, just execute, validate, and execute. Validation is just checking that, okay, this signature follows this SNP standard, and then you execute your transaction. But most of this you get on EVM, you have to follow their wallet system. Like, they have a rigid wallet system that you must follow. So if you have maybe played around with all this, you notice what I'm saying. Yeah. So now, what are the core principles of account abstraction? Excuse me. Okay, what are the core principles of account abstraction? We have nonce abstraction. So nonce, I mentioned earlier, is numbers that are used only once. Number plus ones is nonce. So these are numbers that is like a number tracking the number of the transactions you do. So if you have done 10 transactions from your wallet, assuming you do 10 transactions on your wallet, your nonce will be 10, showing that you did 10 transactions, 0 to 9. So if you do 20, the same thing, you have 20 nonces. Yeah, so, but on EVM, you don't change, you must follow the 1, 2, 3 pattern. But with smart wallet and apps, account abstraction, you can implement your nonce anyhow you want. So they allow smart contracts to manage how and when transactions are ordered instead of relying on single strictly incrementing number. Just what I just mentioned. So instead of relying on just increasing the nonce plus 1 for each transaction, you can order your transactions any way you want it, and it will still work. So I mentioned programmability. Yeah, when you have programmable logic, builders can customize their wallet according to their specifications. The only requirement is that you follow the standard on SNP 6. That's the only requirement. But aside that, you can customize your wallet anyhow you want it. Signature abstraction, you don't need to follow the rigid signature system. You can sign your transactions using Face ID, fingerprint, and passkeys. Yeah, so even some new tools now, you don't even need to just send the transaction and they do the signing for you. They do their own checkups for your account. They do their own checkup, make sure that you have this, and then validate that transaction, and then they sign the transaction on your behalf. And that's how cartridge system works. They now create a transaction for you and send on your behalf using your details. So yeah, that way you can use Face ID or fingerprint and passkey to sign your transactions. So fee abstraction, I've mentioned that users can pay gas fees on Starknet using any fee of your choice. Even if you have a meme coin, you can use it. So recovery abstraction, you can recover your account using Gmail, email. So any email at all you use to create, because at the point of creating, they will require an email from you. So that email will serve as your access, both verification and 2FA, two-factor authentication. So yeah. Yes, so this is where we end this for account abstraction and Starknet architecture. So I want to check if does anyone have any questions? Okay, no questions. So we will jump to the other side of the meeting. So this is not the end. Yeah, so let me get to the other side. Yeah. So yes, we are done with Starknet architecture and account abstraction. Now we go into Cairo programming language. Yeah, so I mentioned earlier that Starknet is the protocol. The language you use to write programs or smart contracts on the protocol is called Cairo. Yeah, Cairo is almost Rust, so it's similar to derived from Rust programming language. So in the last class, I mentioned that if you understand the Rust, it will be easier for you to follow up with Cairo. So it's almost the same in terms of memory management, in terms of ownership. That's what we call ownership in Rust, ownership also in Cairo language. So yeah, let's get started. So what is Cairo language? So I mentioned that Cairo language is Rust-like. That means it's like Rust. It's Turing complete programming language used for writing provable programs. Question now is, what is provable programs? So I mentioned during the architecture that we have a prover that proves every transactions and then sends to verifier. So provable program means that we are building, I don't want to use too much technical terms so that everybody can follow. So when we talk about writing provable programs, it means that the compiled program you wrote can be used by the prover to generate a proof. I think it's that simple. The compiled, anything that you write, any program that you write, any smart contract that you write using Cairo language, after compilation, it can be used by the prover to generate a proof that can be verified. So that's when we say provable programs, that's the meaning. So features. The memory model of Cairo is similar to Rust. So I don't know, probably later we'll see how these things work, so that let's just continue. Maybe I'll show one or two things on the code today, or probably next class. I don't want, it's already going to 1 hour. I don't want to waste much time today. Let's just do this, then I give you something to read and study. Now, next class, we start writing code. But for now, let's look at, so memory model. Cairo applies immutable memory access. This means that once a memory slot has been written to, it cannot be changed. So there's what we call slot. In Solidity, I think most of us know what Solidity is, and have written Solidity language. Yeah, if you have tried assembly small, if you have tried to write assembly language small in Solidity, you know that most times you're handling slot and you're doing up codes like mload and sload and the rest. Yeah, so don't mind me. It's just that it's crazy, honestly crazy. Forget about mload and just what I just mentioned. Is advanced part of Solidity. So it's called assembly language, but that's by the way. So what happens is there's the concept of slot is when you have on the computer memory, how memory works is you have your memory like this, like trying to present this graphically now. You just have your memory like a box, and that box is divided like in columns, column. So each column is a slot. Each column is a slot. So if you create a variable, maybe you have your program and the first variable you create is occupying slot 1. That slot 1, once it's occupied, you cannot change what you have put there. So when you say, assuming, look at the sample, when you say let x is equal to 5, that 5 is occupying slot 1. If you turn around and say x is equal to 6, it's not going to go and remove the 5 you have. It's going to enter into a new slot on the memory. So memory is immutable, so that this is to improve how memory works and memory corruption. It's easy to mix all these things up when you're writing systems program. So to avoid that tendency of making that mistake, Rust and Cairo uses immutable memory pattern. Yeah, so once you write to a memory, is occupied unless you delete what you have there and put a new value. So variables are immutable by default, and I'm sure we all know what variables are. So when you create a variable, you can't reassign a value to it unless you add mutable to it. So let's see the sample you have. Let x, this is small letter L, by the way, just the typography. Let x is equal to 5. So when you do let x is equal to 5, and then we want to do x is equal to 6, it's going to throw error. So after, I'm going to show this later, maybe before we end today. So it's going to throw error. It's going to simply tell you you cannot assign a value to an immutable variable. If you want to assign a value, maybe consider adding mutable to it. And the way to add mutable to it is just this. Before the variable name, just add mut for mutable. So once we have let mut z is equal to 5, it will tell the compiler that okay, the developer or the engineer wants to change. He wants this value to change. That he wants the value this guy is pointing to change. I don't think you are not necessarily changing what is here because it's immutable. Remember, you are changing what z is pointing to. Again, you have memory pointers, you have memory access, and you have pointers. Pointers are like, you guys need to, I think many of you might even know this. Just do small research on memory pointers, memory addresses. You have memory addresses, you have pointers. So you can just read up on them and see how it works. So what happens is, instead of z pointing to 5, when you declare this z, the z here will be pointing to 5. So the U8 you are looking at here is the data type. We are still going to meet it later. So instead of z, when you declare it, z is pointing to it has what we call memory address, and that address is what this is representing. So instead of having that address, it's a hexadecimal stuff number. Is it a number? Yeah, it's a number. Hexadecimal number that starts with 0x, 0x. Instead of having it here, we replace it with z. So what does z? If you follow that hexadecimal stuff to the computer memory, what we find there is 5 in binary format, of course. But then when you now do z, you return and say, okay, z is equal to 6. What happens is that instead of z pointing to 5, if you now follow that memory address, it will point to a new slot that is 6. So instead of having 5, you have 6. So the memory address is pointing to a new slot in the memory. If you go to that slot, you find 6. But above the 6, you still have your 5. So But then I'm just trying to explain that variables in Cairo are immutable by default. Any questions? Server when I try to install cannot be updated, please. Require upgrading ASDF. Oh, okay. See what happens. This guy. See what happens after the call. After the call, I need to rest. Like I just came back from lectures and jumped on the call. So maybe tomorrow, if I come back from school tomorrow, I will help you and walk through this. There's the documentation I will send to you, by the way. You can use ASDF to do the installation, but you have to first of all install ASDF in your system. So we get to this later, maybe after the call today or tomorrow. I'll drop my number before the end of the call so that you can send me a message on WhatsApp. We'll now continue from there. Okay, that's the only question we have. Oh, okay. Please, how does the paymaster work behind the hood? And I like to understand the architecture of it. Okay, paymaster. Yeah, paymaster is how paymaster works is so I don't have access to this board. I like to, no problem though. How paymaster works is a smart contract, by the way. So if you integrate it into your system, at the point where someone wants to send a transaction, you have to make a call to the paymaster to make a transfer of that gas fee. So paymaster is going to transfer the gas fee to the transaction, and then the user can now send. So the user has sent the transaction. He doesn't know anything about paying gas fee and the rest. But behind the hood, the system is calling the paymaster to send the gas fee for that user. Okay, the architecture, it depends. You can there's no rigid implementation for paymaster. You can build your own anyhow you want it. It basically how it works is going to just be a smart contract that has token and an address. So the address is what will pass to the smart contract. So once it's time to pay gas fee, it calls the address to transfer token. So the address transfers the token behind the hood to the system, and then the whole thing now goes through. I think you can really you can make more research on it, maybe at your own convenient time, and see how it works. So, but then on Starknet we have Avenue. Avenue is one of the DEX. Is it a DEX aggregators we have on Starknet? So they have this paymaster that you can just, I think it's just less than 10 lines of code, integrate it into your system, and everything works. So, but you can just research on it later. I have not built or even tried to build one. Yeah, what we have that comes close to it is there's, I don't want to show the code. There's a system we have on our backend for current pay off-ramp system. So we are using cartridge controller. Now for every controller we deploy, that for every user that deploys the controller on our platform, we pay gas fee for the deployment. So how it happens is that we have our private key and we have our address. So the system, we just built the logic for the system to transfer 0. We just transfer 0.5 stack token to that user, to the newly generated controller. So once we transfer it, we now deploy that controller, because without that token, it cannot deploy. It requires gas fee to deploy. So before deployment, we do the transfer, then we deploy. So that's what we have that comes close to how paymaster works. Okay. So you can make more research about it too, by your own self when you have the chance. Okay, so let's get back. So non-determinism, you can use different algorithm for. Yeah, I just built. So recently we are building a privacy system. All this privacy, maybe swap using zero knowledge, ZK. So we have different. It's crazy. We have totally different Cairo programs that we use inside smart contract. So it's non-deterministic. You can build anything you want, anyhow you want it, and it still works. So Cairo gives you the flexibility to break. How do you say it in Ethereum? Is go fast and break things. So it gives you the flexibility to do anything, build anything unimaginable that you want to build. So I stopped writing Solidity because of too many issues. You have stack too deep error this side. You have contract max size of I think 20 kilobytes the other side. Many things. So it's frustrating. But with Cairo, nothing like that. I think the minimum, the max size of Cairo programs, I've forgotten, but I think it is around maybe 20 MB or so. So I don't think there's anything you can write in code to reach that amount. It's not even possible. And there's nothing like that too deep. So you have if you want to have a million variables, both local and global, you can have. So I have not met anything like that too deep error in Cairo. So it's way more advanced than what we have in Solidity. Yeah, but by the way, that's why many developers don't like Solidity. So execution environment. Cairo runs on virtual Cairo CPU, like is Cairo virtual machine. Yeah. Most of these blockchain smart contracts languages, they have their own virtual machine. You have EVM that runs Solidity. So it's Ethereum virtual machine, the same way you have Cairo virtual machine that runs Cairo programming language. So the execution environment is on virtual CPU. So the when you compile a Cairo program, it goes first of all to Sierra before it's now compiled again down to Kazim. I mentioned Kazim in our last class. So Cairo programs are compiled to Sierra. Sierra is just an acronym for Safe Intermediate Representation. So it's like when you compile your Cairo program, it first of all stops at Sierra. It's doing the first check to make sure that okay, the syntax is correct, maybe the validations are correct, there is no error. So that's the first gate you have to stop at Sierra. So Sierra does the check and then it continues. If everything is valid, it continues to Kazim. So Kazim is the last bus stop. So once you have Kazim is the one that can be sent to prover to generate proof. So yes, Sierra is just an intermediate. Intermediate is even in the name Sierra, which stands for Safe Intermediate Representation. So intermediate is in between the code and the Kazim end result. So the Kazim is being proven, is what is now sent to prover. And you generate your proof. So comparing Cairo with Rust, let's look at the similarities. First of all, you can use your normal macros, Rust macros, like print line and assert. You have assert without a question mark, or sorry, exclamation mark, and you have assert with exclamation mark. Even you have other assert like assert equal, assert every other one. So it's also available in Cairo. Use of crates to import libraries or functions. Also, you have use keyword for importing packages and the other methods. So we see all these ones later. You have variables are immutable by default, immutable memory access. So Rust also have this. I mentioned it earlier. You also get all this in Rust. So differences is Cairo is executed on Cairo virtual machine. That's virtual CPU. So Rust runs on the machine. So if I'm running a Rust code, it's running on my laptop. But if I'm executing a Cairo language, it's running on virtual machine. Once we deploy it, it's running on maybe the nodes and everything that is running the Cairo virtual machine. So Cairo is non-deterministic. You can build it anyhow you want and get the result at the end. So Rust is deterministic. So Cairo is used for building provable programs, and Rust is used for general purpose programming, like web development, like games, like your backend, your APIs, or your REST APIs, and the rest. So Cairo compiles to Sierra and Kazim, while Rust compiles straight to binary. So it's one of the reasons why Rust is very fast, is because once you compile Rust, it goes straight to binary, to machine language or machine code. So it's faster to run Rust than other languages like Python and JavaScript that you still have to like compile first to use, I think, lib v or something. I don't want to go astray much. But JavaScript, you have your libv or something under the hood that compiles your JavaScript to one other language before you now get something that now compiles it down to zeros and ones. But Rust is going straight to zeros and ones. That's why it's fast. But then Cairo compiles to Sierra and Kazim. That's the difference from Rust. Okay, so this is how a Cairo contract looks like. So I don't know if I don't think I can go into writing this today, but maybe in our next class we start off. So mod, the same way you use mod in Rust is the same way you use it in Cairo. No difference. So mod and the name of the contract. First of all, I have to annotate that is a contract by using #Starknet contract. That's the only way it can recognize that, okay, you are building a contract. Otherwise, it's going to see it as a program. There's a difference between Starknet Cairo program and Cairo contract. Cairo program is just your normal backend program that you write, that you must have a main function that you can now use to coordinate every other functions and stuff. But with a Cairo contract, you don't need a main. Just annotate that I'm building a contract and then start off. This is the contract name. And then this is how to import. Maybe you have to do a lot of importations when you are writing Cairo. So you have to import. This is for you to be able to write to storage, to Cairo storage. For you to be able to store anything as a global variable in Cairo, you have to import this storage pointer. Right? I mentioned pointer earlier. Storage pointer read access for you to read what is inside the memory, and the write access is for you to write. It gives you access to 2 functions or more, but the major 2 functions are these. This write access gives you access to this write function, so you can call write functions to write anything inside this place to the what you have in your storage. So like this, you have self dot to refer to what you have in your storage. You first of all, you must use a contract state here. So when you use contract state, is referring to this self, and this self is this, like, is referring to this struct that we are using. This struct is an interface. So we see all those ones later. So self is referring to an interface, and this interface has functions in them. Okay. So when you call this self, it's referring to the whole contract state, and the contract state is this. Majorly is this. So when you down do self dot, when you do self dot balance, self is the contract state. Then if you do dot balance, it gives you access to what you have inside here. So self dot balance dot write. So we are going to see why we have this. Because yes, most people will, why not write self dot balance dot write amount? So you just store amount to what you have instead of doing you read first before you now add. So why not just do, just do dot write, no need for this, just write the amount straight. We are going to see all this later. Then to read what we have in memory, just use self dot this balance dot read. So the read we return the balance you have in your storage for you. Okay. So this is basic overview of Cairo syntax. Yeah, so we will still see all this later. So if I have time today, I might just play around, maybe just write one or two things for you to now have a feel of what it looks like. But the next class we will do it in deep. So this, I believe everybody have installed this, so there's no need for this. Now, principles behind the Cairo language design. Let me check if you have questions. Okay, how can we get this class recording? My network has been skipping. Yeah, the class is being recorded, so lucky we will know how to send the recording across. Once it's out, they will send you the link to access the recording. Yeah, so let's continue. Now, the principles behind the Cairo language design. Why was Cairo language built the way it was built with the features it has? So first of all, this Cairo was built from first principles. It's normal on blockchain to see people just copying and pasting what maybe other people have. But whatever Starknet is building was built from first principle. And that is why their architecture, their engine and everything is totally different from what we have and more efficient. So it's not every day that you see one protocol settling on both Ethereum and Bitcoin. So it takes a lot of work and system design to achieve that. So why did we have all these features in Cairo built into Cairo language? First is it was built on zero knowledge technology. So you have to prove everything. Not in all transactions passing through Starknet they generate proof for all of them. So that is one of the principles. And I mentioned that when you compile a Cairo language, first of all, you compile it down to a Sierra, self-intermediate representation. And then if everything is valid, we now compile it to Kazim. So that's the benchmark. Now that Kazim is moved to Prover to generate proof of what we have. So once anyone runs that your contract, it generates a proof for it. And then it's added in the block. So that's the normal flow of everything. So it's prove everything by design. So it's safe, it's memory safe. Like I mentioned at the beginning earlier, no matter what you are doing, once you write to any memory slot, it's taken. You cannot change what you have there unless you delete it and then rewrite. But once it's memory safe, as you cannot corrupt the memory easily. Yes, you also have what we call ownership that also checks this. Yeah, you can write it down, ownership in Rust and Cairo language. Maybe you can study it later. So you have the intermediate representation layer. What I called Sierra earlier is self-intermediate representation. It's where you first of all check the code you wrote, whether it's valid according to the specification. So if it's valid, we now move. First of all, the syntax of your code have to even be correct before you even compile. Because if you have compile time errors, the program will not even compile at all. They say that some errors, maybe assuming some errors past the compile couldn't be caught during the compile time. When you compile down to Sierra, it will be picked out, and then they return an error for you to make the correction. So that's why you have this. Instead of going straight to Kazin to prove it, which will be costly, we have this first stop that checks everything and make sure that is according to standard before we now continue, because proving is expensive if you don't know. So we have deterministic execution. So I'm not going to explain this. All of us are developers. We know what determinism means as a developer. So if you don't know, just Google it later and check for yourself. Now, trust the math. So yeah, this Cairo language, I mentioned that it does a lot of mathematical computations. Yeah, as a matter of fact, the prover is a very giant machine. Is most of now 100, let's say 99% of the work it does is proving, is solving mathematics. So it's mass intensive. Yeah, so it works with polynomials and all this. I don't want to go into deep mathematical stuff. So working with polynomials is a lot of mathematics. So this algebraic intermediate representation is what is used to create the execution trace. I mentioned the execution trace earlier. That is like a mathematical summary of everything that happens in a transaction. So this arithmetic intermediate representation, AIR or A, is what is used to convert computational statements into polynomial equations. Amen. Yes. So I'm just trying to explain what happens. So nobody's going to ask you to solve any mathematics. Yeah. So don't get scared. I know many of us are math aversive. We have phobia for math, especially when we start writing letters and figures and symbols. So, if you have any question, okay, no question. But I hope you guys can still hear me because rain is falling here. So I want to be sure I'm still being heard. All right. So like I was saying, arithmetic intermediate representation allows the conversion of it converts the transactions into polynomial equations, and these polynomial equations are the ones that is what is now being used to generate your proofs. So the prover accepts this execution traces, and from it generates polynomial equations. Please, can you still hear me? Okay. I will try to be more audible now because the rain is getting heavier. So let me even rush so that we can end for today. So the prover uses the execution trace to generate polynomial equations. Now it uses the polynomial equations to generate the proofs. So it's like that. Like I said, Sierra is not the end product. See, look at what I have here. Sierra is not executable as a file. It must be compiled into Kazin, which is now executed by the Cairo VM. So remember that. So the three main components of Cairo language. I'm trying to round up so that the rain is disturbing much. Three main components of Cairo language is the Cairo compiler. First of all, I have to compile to Sierra, then to Kazin. Like I've mentioned it many times. Now you have the Cairo VM. I also mentioned it some time ago, that generates the execution trace. So it generates the execution trace, like the summary of the transactions for you, like in mathematical notations, and then it passes it to the prover. The prover uses that execution trace, generates polynomial equations, and from the polynomial equations, it will now generate the proofs for you, stack proofs. Now, so what we have is it generates stack proofs for you. So the proofs is now what is being verified by the verifier and stored on the Ethereum layer. So I think by now all of us supposed to have, understood this, because I've been going back and forth on it for many times now. Yeah, so okay, nice. We have almost come to the end of this. Yeah. So we are going to quickly install Argent and Bravos wallet before we end the class for today. We're going to install Argent and Bravos. So Argent is now called Ready Wallet. So I don't want to give you links because I don't know the OS, the operating systems we are using. Me, I'm using MacBook. Some people might be using Windows and Ubuntu. So I will just show you how to get this on Chrome Store. So I also don't know how the browsers you are using, but I'm using Google Chrome. So if you are with me on the call, if you're using your laptop, you can quickly open your browsers and then type in Argent wallet extension. So I have Chrome, so that's why I'm adding Chrome here. So if you have maybe Mozilla Firefox, I don't know if it's on Mozilla, but you can try. If not, you can just install Chrome later and install it. Then you have Chrome, you have which other one? Safari. I'm not sure it's on Safari also, I've not checked. So, but once you have this, just enter. And then the first, you'll see Chrome Web Store, and then you see Ready. It's Ready now, formerly Argent. The former name was Argent, but now it's called Ready. So just click on it, it open up. So if it's your first time, you are going to see add to Chrome here. It's because I have it, see it here. I already have it, so I'm not going to add. So just click on this, add to Chrome, and it will add it to your browser. So you need to install this because we are going to be using it later for both deploying our contracts and interacting with them. So try to install it. Same process with Bravos. So you can just come back here, do Bravos wallet extension, and you see it here, the same thing. Chrome Web Store, you have Bravos here. So just click on it like this, and then you can add the same process, no difference. Oh no, don't remove. Oh, wait, I'm not sharing this. Yeah, exactly. Sorry about that. I'm not sharing this. Okay, can you see the browser now? Oh yeah, yes. So I was talking about Ready. So if you come here, just type in this. Either you type in Argent Wallet or you type Ready like this. It's still going to bring out the same thing. So either you type Ready Wallet or you type Argent. The first this thing here is what you are going to click on. Just click on it and it will open up this page. So when it opens up this page, you go here. You are going to see add to Chrome or add. So this is, if you click on it, it will start the process of installing the extension for you. So after installation, you can easily follow just enter your email and create a password and you are done. Okay. So let's do this. Just follow the same procedure is also what you use for Bravos. So to also install Bravos, just come here. Bravos is double A like this, then VOS. So also install Bravos. Click on it, it brings you here. So the two wallets you need to install are Argent wallet already and Bravos wallet. So by the next class, ensure you have two of them installed. So check the chart. You see an assignment that you are going to do. So it's not much of an assignment. I will need you to create a Starknet program. Just create using Scarb. You see how to do it on the page. So just create a new project using Scarb. Then if you finish creating it, or let me show you something. They have a Cairo extension on VS Code. About that places. Sorry about the drop. I hope you can hear me now. Please indicate, can you hear me? Sorry about that. I didn't know that this thing disconnected from my thing. So I don't know the last thing you heard, but then I was saying that you look at the assignment I just pasted in the chat. Then what I require you to do is to study this, just the beginning of this Cairo book. So create a project, a Starknet project using Scarb. You already installed Scarb, except one person. So create a project. Yeah, so create a project, then you get your, there's a default project inside every new project. So delete it and then just write this for me. It's not much. You don't need to copy and paste it. Just write it by yourself, and then also add another function to. What do we do? Okay, create your function to accept two numbers as argument, and then use print line, and then print the total sum, the sum or the total. Print the sum or the total using the print line. So just the function is just doing two things: accepting two numbers as argument, and then add the two numbers and print the total for me. So when we come to the next class, we first of all look at what you did, and then we now start off. So I think for now we are not using ChatGPT or any AI for our classes. It doesn't make sense at all. So just study the documentation, then try to do it on your own with the help of the documentation. Okay. Yeah. So also, if you have time, the next class is on Friday. So between now and Friday, also try to look at common programming concepts like variables, data types, at least these first two. Study variables and data types, and then do the small assignment I gave you. So if I come next class, I will ask a few questions on these two here, 2.1 and 2.2, and then that's it. We can continue. So let's see. If you have any questions, please ask before we end the class. Any questions or any confusion at all that you have? So this is my number. The guy that is having issues with Scarb installation, 2507. What? 79.